Hello everyone and welcome to section 4.6 in Algebra 2. If you have your online textbook available, this can be found on page 267. If not, don't worry, just follow along with this video. So in this lesson, we're going to be solving exponential and logarithmic equations. There are all different kinds of these equations throughout this lesson. This video is just going to show you pretty much half of the lesson. We're not going to get too complicated today. So the first concept is applying the property of equality for exponential equations. You're going to see numbers, well, bases, that have some type of exponential relationship, and you have to figure out how to make them the same base. So I hope you know that 16 is 4 to the second power, right? So that's what we're going to do first. We're going to change that to be 4 to the second power. Because using this property, you have to make these bases the same. Okay, so I changed 16 to be 4 squared, but then this has to come down as well. So I will bring that down in a parentheses next to that too. Now, once you have the bases the same, the rest is super easy. It's basically just Algebra 1. You're going to take the exponents using the property of equality and set them equal. And just solve. So I can distribute here. That would be 2x minus 10, right? I could subtract 2x to both sides because I want to combine my like terms, and that would be negative 1x equals negative 10. Divide that negative 1 to both sides, and x equals positive 10. Yay, and that is it. Now again, always, see if you did it right. How? Just plug in. If you look at the original problem, if we plug in a 10 here and a 10 here, let's see what happens. You would get 4 to the 10th equals 16 to the 10 minus 5, and 10 minus 5 is 5. So 4 to the 10th power is equal to 16 to the 5th power. And if you were to take a calculator and do that, you would result in the same answer. Okay? So that's how you would check that. Again, that is the first concept. Okay, now I'm going to move on to the second concept, and you will be getting practice problems after this video, after you watch this video. Okay, concept 2 is now when the numbers don't have a relationship. So for example, let's start the same. 4 to the x power equals, let's say, 11. And I'm taking this straight from the book. So if you look at these bases, you notice that they don't have a relationship. Like I cannot turn 11 into 4 to the something power, right? Okay, so that's what I mean by they don't have a relationship here. Now you can estimate, as we did in the previous lesson. So for example, you know that 4 to the first power equals 4. You know that 4 to the second power equals 16. So this x has to be a number in between 1 and 2. Probably a little closer to 2, right? Since 11 is closer to 16. But we need to know the exact value. So how we would do this problem is by now, what you're going to do is we're going to use the inverse properties from before, and we're going to take this base and we're going to do log of whatever that base is, the one that holds the exponent. We're going to do that to both sides. Okay, just stay with me. I know it looks complicated, but it's not. So log base 4, now bring down the original equation. So 4 to the x and 11 here. Okay? Now, if you remember from before, okay, this right here will cancel out, and now you're just left with x equals log base 4 of 11. And again, from applying what we know from before, how would you solve that? You would use your change of base. So change of base says take the log of base 10, your common log, of 11 over log of base 10 again, of the base, 4. Okay, and then you would just use your calculator. So you would type in log of 11 divided by log of 4, and that is approximately 1.73. I would say always round to at least 2 decimal places. Okay, and now again check your answer. So you could plug that in to the original problem. 4 to the 1.73 should be approximately 11. It might not actually be 11 on the dot, but it's very close to 11. Okay, so that is concept 2. That is taking a log to both sides. All right. And I will be teaching you one last concept for, actually two more. So my next example, which is actually, I think, the easiest example so far of this lesson, you're going to have a log already in the problem. And again, I'm taking this straight from the book. So this is I think easier, and the reason is because when you have already a log on both sides and these logs match each other, so notice log base 5 equals log base 5, the beauty of this is these now will just kind of go away for a little bit because we're using the property of equality for logarithmic equations. So if they're equal, which I'm not going to, you're not going to get a problem where they're not equal, so don't worry about that. These now are going to equal. So 4x minus 7 equals x plus 5. And again, it has become just a basic Algebra 1 equation. So we're going to combine our x's. So let's subtract this x to both sides. And I'm going to add this 7 to both sides. So do two things at once there. And now I'm going to have 3x equals 12. And divide that 3, and we have 4. Okay? So, and again, plug it into the original equation, and you'll see that it does make both sides equal. And the book shows you that too. This example is from page 269, just in case you're curious. Okay, and again, that is when you have equal logs on both sides, you can do that. All right, and now one last example in this video. Okay, so now this problem, notice, it only has a log on this side. It does not have one on this side. So we can't just say 5x minus 1 equals 3. That would be incorrect, okay? What we need to do, and again, this all just keeps coming back, building on previous concepts, is we can do the snail. So that would be 4 to the third power, using the snail method, equals 5x minus 1. Okay, so I did the snail. I'm actually doing, this is on page 269 as well, but the book shows you something a little different. I'm showing you something that you learned before, so hopefully this makes sense to you. Now I'm going to solve. Again, simple Algebra 1. So 4 to the third power is 64. 64 equals 5x minus 1. I'm going to go ahead and solve for x. So I'm going to add that 1 to both sides. And so 65 equals 5x. And divide that 5 to both sides. And x equals 13. And again, plug that into the original equation and you will see that it works. Okay, I hope you have understood and you will be getting practice problems to follow. Have a great one.